Here we have a pulse signal that we're capturing. That's a series of about 7 pulses that occur over time. Um, it's nothing really to be too interested in terms of the time domain characteristics, but if we look at the FM measure time, we can see that the frequency of these pulses change over time from pulse to pulse, and it's repetitive from pulse train to pulse train. And we could see some interesting artifacts of this in the pulse table, and we could see the frequency that they hop to over time throughout the sequence. And we see that it's a little bit slightly different from train to train. Like for example, if we start again on pulse 8, pulse 1 is about 65.5 hertz, pulse 8 is about 17 hertz. So there's some oddities here, but it's something that we want to look at a little bit more detail. Maybe we want to understand the hop settling time, maybe the hop states and things like that. And you could do some of this with direct inspection with markers, but it comes a little bit cumbersome. So what we can do is we can use the power of the pulse properties menu here in the analysis tab. And if we go to the hopping analysis here, we can simply turn this on, and it's really powerful in the sense that it does quite a bit of automatic measurements. And you can see the pulse table, we have a whole slew of new measurements available, from hop state index to the start of the hop to the end of the hop, the settling time, the dwell time, switching time, etc. And this is really useful because now we could see that there's a clear pattern to this hop, aside from visually, but also parametrically. We could see pulse 1 is our first hop stake index, and then pulse 2 and 3 are very close to one another in terms of frequency, and which is verified by the average frequency measured as well. So we can call that a hop stake index of 2. And then from 2 and 3, we go to an index of 4, which we see is at about 20 megahertz. And then pulse 5 and 6 ends up being another frequency, which is about 30 megahertz. Then lastly, pulse 7 is 40 megahertz. So it ends up being a sequence of 1, 2, 2, 3, 4, 4, 5. But more importantly, we get a lot of the information of how fast it takes to hop, how long does it dwell at that frequency, as well as what's the switching time between between hop states. And there's a lot more settings that you can play with in here in terms of what's the setting tolerance for a particular hot state. What's the maximum hop time that we want to look for in terms of dwell, or the minimum? What's the analysis of the pulse that we're going to make this measurement on for the dwell time? And so on. And a lot more information about all these different settings can be seen within the help file here, like settling tolerance, sets the amount of settling in hertz to allow for at the hop edges. So at what point do we want to call any frequency deviation or error from a settled state as that actually being the settle versus something that's still settling in on its hop index value. So really powerful tool here.